So I don't know if you needed to do that, if you guys were done. Looks like only 100 also only calculations. Looking clearly, looks like it has a focus on. And then, because we finished the calculation. Do you remember which ones were yours and which ones were hers?
Yeah, mine are the 5.
Okay, so why don't you go ahead and complete your calculations? And then as soon as everyone is done with their calculations, I do want to talk about, how to use this information next. So what do we mean by once we get all these measures of central tendency and dispersion? As you guys were working on this, I was creating a sample of my own so I could show you how to do this. So let's give you guys a couple minutes to finish whatever final calculations you might have. This is what I'm seeing. There were a few numbers missing on the bottom when I looked at it before coming down here.
Gotcha.
But I don't know who.
You just barely finished it up.
Okay, so yeah, I couldn't remember who had which numbers, which samples, so I just figured. You guys would be having class and- Okay, so just to refresh your memory, remember we were using the count function just to count how many numbers we had. And we wanted to make sure each of them had 10, which looks like you guys did get that. For the mean calculation, remember the function is actually called average in Google Sheets, or if you're using Microsoft Excel, it's going to be pretty much the same functions. If you are doing median, then thankfully it is called median. And then you just select your data set. For mode, this is the one that I was talking to you guys about using the multiple mode function, just because we don't know if our set will have only one or many. So you were using the mode.mult or the multiple one. So mode.mult. And if it only has one, it's going to spit out one. But if it has more, you will see it gives you a number next to it. So what I was doing was identify those, but then you can just come in and type by hand. So you can say 54, 61. So that way you had two modes in there. So it's okay if you don't end up using the function in there and typing, because I can always figure that out, by using the function itself. But you want to make sure you're using the multiple modes so that it automatically shows you what numbers were occurring the most often. For mid-range, this is where you didn't have a built-in function. So remember, this is where we were taking the maximum value. So we're using maximum. And then we were adding the minimum to that. So that's our minimum function. So again, you select the data set. So we put the maximum plus minimum, remember, in parentheses so that you could do the addition first. So put that in parentheses, and then you were dividing it by 2 so that it would calculate, basically takes the largest value and the lowest value, adds them together. You take its mean or divide by 2, and you get the mid-range. Now, range, on the other hand, is just a simple subtraction plus you. So you take the maximum value and you just subtract the minimum value from it. Now, remember, mid-range is a calculation for finding your measure of central tendency. So that's an average calculation, whereas range by itself is a measurement of dispersion. It is to find out how spread out your data is. So even though the names may sound familiar, they have two very distinct functions. Now, when we were using the all ages, remember we used the standard.deviation.p as our function value, because this was our entire population. But once you guys started doing your samples, and this is kind of what I was just telling Drew right now, you are using the standard deviation.s because now you're working with your samples. So you want to use the .s function when you're calculating your sample standard deviation. So again, those of you who have already finished your calculation, just make sure you had those right functions in there and you guys should be good to go. So I am actually, once you get that one function typed in, honestly, just select those, take your mouse to the bottom right corner, and remember you can take it all the way to the 10 samples and it'll calculate all the mean and medians for you. The mode is gonna be the tricky one since these ones we do need to figure out what the multiple modes are, so we will do those individually. Because you don't wanna see this guy have 3 of them, now let me just copy that over to the other functions and then we can type this. So looks like we have 55, 58, and 60. 44, all of these were just no mode, so that's great. Then 3 on the last one, so this one had 49, 51, 54. And then we should be able to copy these over for the remaining 3 calculations. So honestly, if you can get one of them done, you can almost, translate that to the other samples.
So that one is, the P function is just for the population, the S is just for your single samples.
For your samples, yeah. And that will be what you will also see in your homework problems, because they will describe some of them as population, some of them as samples, so that's kind of where they want to know if you know the difference of using the different form.
That was my question, one of my questions. So that's why I
Okay.
was like, "Look, I know we'll get there eventually."
Okay, good, 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 very nice. All right, looks like maybe you are almost done as well. 45. Thanks. Hope you guys to see all the data. Alrighty, so I think all of you are caught up with that. So looking at each of the 10 samples, and you need to do this for your own data set. Between the mean, median mode, and mid-range, which one are you seeing more consistency with? So where, the numbers would be more closer together for all 4 of those calculations. So if you had to pick which were your more consistent sets, which ones would you say?
Three choices of mean, median, and mode.
And mid-range. all
And
4.
mid-range.
Yeah.
I would probably say my median, sorry.
No, so you're looking at each sample and you're trying to see out of those 4 calculations in each of the 10 samples, which, like sample number 1, sample number 2, which one is more closer together in all 4 of those calculations?
Oh, okay.
Because then that tells us, we kind of have an evenly distributed set if all 4 of those calculations are, closer together. I'm seeing at least one of them in use samples. And at least So Paulina and Drew, which one would you say was more consistent for you guys? No, again, you're not looking for just a single calculation. Out of all the 10 samples, you're looking vertically. Out of all the 10 samples, which sample set has all 4 calculations closer together? So mean, median, mode, and
Ten.
the only problem with 10 I had was you had 51.6 for the mean, but the others were obviously all at 55. So let's find something where those 4 numbers were all closer together.
Also 7 or 8.
8 is looking good. Yeah.
7.
Anything else standing out to this? 4. 4. Yeah, 4 is looking pretty good too, because you're right around that neighborhood of 57. Yeah.
So 6.
6. Well, with 6, the mid-range drops a little bit because you're closer to 53 on that one. But yeah, those other 2 were good. Vacant Honey, what did you guys say?
I'd say the one that's probably the most consistent is gonna be our 7.
7, yeah, 7 looks good.
Our lead up would probably be 6.
Yeah, I mean, your mode obviously goes between 3 numbers, but the lower number definitely stays closer to the others. Anything else in there?
I feel like really close to
Yeah, but you are still kind of jumping from 51 to 55, so a little too spread out, I would say. So why did you have 93, 84, 90, 93, 92 as the mid-range on those first 5 sets? Yeah, they are way too high compared to your other 3 numbers. So maybe once you fix that, you may see more options stand out. Libby, what would you say for your sets? 4. Yeah, I can see 4. Yeah, my only problem would be that 51. But you said 6, right? Or did you say 4?
I said 4.
4. What about 6? 6 is not too bad. Are those 2 the main? Actually, even number 5, because you do have one of those modes of 56 in there. So those would be pretty close to each other, right? So what that tells you guys, when those 4 calculations are closer together, we're basically saying our data is evenly spread out, because that says that we have uniformity between our numbers. And even if you just look at whichever ones you pick from your set, if you look, you will be able to see that those 10 numbers that you had in your sample are close together. You're not seeing a lot of variation like low 40s or big 70s, because remember our ages were going from 42 at the youngest to 78, I think was the oldest. So that actually tells you your data is pretty close together. Now remember, your range will tell you how spread out your data is. So you can see, again, the idea is the smaller the range is going to be, the closer your numbers are going to be. So look at this is I think this is Paulina and Drew's numbers I'm looking at. So you guys have a range of 6. Look how close those numbers are. And with the exception of that mode, I mean, all the other 3 numbers were pretty close together, which would be your next 9.5. Is the smallest range after 6? Yeah. So these guys, again, looks like you're going from 48 to 65 as your largest number. So still pretty small. So look for the range that has the smallest number in all 10 of your data sets, and then compare that with the 10 numbers in your data set. So Vic and Haley, what would be the smallest range for you guys? 15, no, 11? 11 is the smallest, isn't it? So yeah, okay, now you can see those mid-range numbers are looking much better. So in that case, with the exception of the mean, even your number 2 seems to be pretty close to whether, I mean, 3 of those 4 numbers are matching, but yeah, I think your 6 and 8, no, 6 and 7 were probably the closest. So again, for number 5, if you guys just look at those 10 numbers in your sample, you would see those numbers are pretty close together. They're not very spread out. For Emily and Libby, what is your smallest range? So it looks like Drew and Paulina had the lowest one because they had a set which is 6 as their range. But yeah, again, Libby, you can see in number 5, you're starting out at like, looks like 51 as the smallest one. Going up to 64, so yeah, that's your range of 13, so pretty close together. So range is one way to know how spread out your data is, but you can also look at standard deviation. So can you identify which of your sets has the smallest standard deviation, and does that match with your range as being the smallest number in your dispersion calculation? So for Drew and Paulina, that is definitely true. You can see, and that's this sheet I have up here. You can see they have 2.5 as their smallest standard deviation, which just does match 6 as their smallest range. Look at their data set. It basically is all in 50s. It's going from 51 to 57. So what the standard deviation actually tells you, and it's interesting, the standard deviation is actually almost the same as an average calculation, because what a standard deviation does is we take our mean, remember, and you subtract your data value from the mean. So that basically tells you how far away you are from the mean. And then to avoid the negatives, remember, we squared that, added it, divided it by our n-1, and we take a square root if we did it by using the formula. Of course, we're using the built-in function, but you're still doing the same calculation here. So what the standard deviation tells you is, on an average, how far away is your data set from the mean. So we are saying on an average, all 10 of those numbers are approximately 2.5 units away from your mean, which in this case, you guys had 54.1 as your mean. So we're saying your data is actually much more closer to the mean. But if you look at your highest standard deviation, which would be what? The 8.4? Yeah, 8.4, and you can see that was almost the highest range also you had. You did have a range of 24 here, but 23. So look at how spread out your data is there, because your lowest number seems to be, what, 47 here? And the highest one is 70. So you can see that data is spread out more. So that standard deviation is 8.4. So we're saying on an average, each of your data values are 8.4 units away from your mean of 57.2. So that data is more spread out. Their standard deviation of 2, which was number 9 for their sample, is much more tighter, right? It's much more closer. Let's look at Vic and Haley. What did you guys have in your smallest standard deviation? You see the 3.8. I guess he is the smallest one, isn't he? And was 11 your lowest number for range? Yeah, I don't know why you have that gray on there, so that keeps throwing me off. Like on the
What? Okay.
But yeah, so you can see for Vic and Haley also, their smallest standard deviation does correspond to their smallest range number. And again, in that, which is number 5 for these guys, you can see their data set is going from, is it 54, the smallest number? And 65 as the largest one. So again, very close to the mean. So this is telling us that all 10 of those data values are approximately 3.8 units away on an average, away from your mean of 55.0. So very nice. And looks like your largest standard deviation is 7.7, which happens to be with the range of 24. And this tells us your data is more spread out. So if you compare set 9 with set 5, you will see there's a distinct difference of how spread out those data values are. So standard deviation really comes into play, especially if you're making like comparisons between two sets, because then you can kind of decide, you know, if you need something more consistent, more closer to the mean, you want to look for a smaller standard deviation. If you need something that is more spread out, then you of course look at the larger standard deviation. And then let's see for Emily and Libby. What's your smallest? 4.5? Which does correspond with your smallest range also. So this would be your data set number 5. So you are looking at the smallest number is 51. I think I already said that, and the largest as 64. So again, we're saying same thing. On an average, your data is spread out by 4.5 units away from the mean. And in this case, your mean was 56.1. And then what is your highest standard deviation? 9.6? Yeah, and that seems to be corresponding with your largest range value also of 27. So in this case, it looks like your lowest data value was 42. And the largest one seems to be 69, yeah, which would give you the 27 distance. So you can see that is more spread out. So that's kind of where you use your standard deviation, because like I said, we're basically talking about how far away from the mean are all your data points in your given data set. And that's what standard deviation does. And you will see in your textbook, they actually do talk about that interpretation. And they're of course using this with the sense of an example here, but they are saying if you're comparing two populations, then the larger the standard deviation, the more dispersion the distribution has, which means more spread out your data is. So the larger the standard deviation, the more spread out your data is. The smaller the standard deviation value, the more closer to the mean your deviation is going to be. And when we actually talk about normal distribution in chapter 6, you will again see how this ties in together. We'll be doing a little bit of the empirical rule in chapter 3 just to introduce you guys to that idea, but we'll deep dive into normal distribution in chapter 6. So yeah, I guess we're just kind of introducing that concept to you. And you can see right over here also in this example, they're talking about determining whether University A or University B has more dispersion in its students' IQ scores. So in this case, you can see they used a different technology, the minicab, but you can see their calculations here. We've got their mean for the two universities. You can see we have their standard deviation. Now, since the mean was the same, it doesn't really tell us much, right? Because both the universities have 100 as their mean. So the mean wouldn't be able to tell us which data is more spread out and which one is, you know, if the mean were closer or further away. So in this case, we only have the standard deviation. So look at the two numbers here. I mean, there's a difference of double almost there. You have 8.35 for University B, 16.08 for University A. So what does that tell you in terms of IQ scores? If there's more dispersion on University A and less on University B. Because if the mean is 100, we're saying that's the IQ score mean, right? So the mean of how many of our students they had comes out to be 100, and a standard deviation comes out to be 16.08 for University A. So what does that tell us? Yeah, it means they're more spread out, right? So University A is basically saying we have more spread out of our data values, because look at their minimum IQ score was 60 and the maximum was 141. And for University B, the lowest IQ score was 86 and the highest is 119, right? So we would say B has a more consistent data because those numbers are closer together, right? They're not spread out as much, whereas University A can go from 60 on the IQ score to 141. So that's a big spread. Doesn't mean one is better than the other. It just means you are seeing a wider range of data on University A's student list than you are seeing in University B. So a lot of times standard deviation definitely comes in handy when you're trying to do a comparison between two data sets. And like I said, we could do that comparison between our 10 samples that we have done. So one final calculation you guys need to do is calculate the mean of sample means, which means you are finding the average of all these means here. So what will that average come out to be for each of your samples? So you're finding the average of all the sample means, basically. So same function, you're going to use average.
So just the average, right?
Just the average for the means, not the other calculation, just for the. And that's going to go under the mean of sample means. Now, the idea here is, guys, if you did your random sampling randomly, right? There was no personal influence, like you had asked me what happens if there are repetitions and the numbers, should we avoid those or not? So if you did this randomly, that mean of sample means should be very close to the mean that we did for all ages. So this is for my example that you guys are looking at. It should be very similar to this number here. So that actually tells us that if you do your random sampling correctly, your mean of sample means should come out to be same or at least close enough to your population. And this is also something you will actually come across as you move forward in different chapters here. So let's see what did our group one get for their. So we've got 54.4. So you guys are about a unit away from the population mean. Let's see for Dick and Haley, you guys have 53. You're actually a little bit on the number then. You're a little over 2. And then looks like you are at 50. So you are the closest one out of all of us to being close to the population mean, 55.4. That's good. So Vic and Haley, what do you think happened here for you guys to be kind of on the lower side of that?
Probably sample 5 where they had such. Well,
Because this actually tells me there's something wrong in your data. If you're that far away from the population. You guys are good because yeah, you can have a difference of 1 unit, but 2 units is a bit too much.
it's super high.
I'm just wondering, yeah, if
It looks like sample 5 has more of a really high numbers and the rest of them pretty even.
so. Yeah, I'm not entirely sure unless we can go back and redo the whole thing, but that doesn't make sense. But yeah, the idea is you're looking for, those 2 means to be really close to each other, because like I said, that tells you had a good sample. And sometimes it could be freak of nature that maybe you didn't do anything wrong. You did as randomly, you were able to select your data values, but maybe it just tells us that maybe this sample was not good enough and we need to start over. And that is something you will see in some of the studies. They will do these groups of sampling, right? So they may do one in this area and then go and do one in the other area. Kind of like we were talking about, if we were using our state as our kind of background, then, maybe we did this around Denver metro area, but then we're like, no, let's move to the western slopes and maybe do the experiment there or whatever, and you may get a different result. So if you shift from area to area or change your sampling, sometimes you can see your results will change. So that can be that maybe just the way your samples came out, they are turning out to be a little bit lower in that mean of sample means than what our population mean should be. So a lot of times, if you remember, we had talked about those confounding variables that have effect on our study, though we were not, wanting them to affect it, that could be part. So we don't know. Alrighty, so that's about it as far as this guy goes. So any questions on making these calculations with Google Sheets? Now, there will be some examples in your homework which will ask you to do by using the formula. But for the most part, where they just ask you to find your calculations, you can use Excel or Google Sheets to do. Okay? All right, guys, let's get back to our textbook here. Let's clear this one. All right. If you remember, I had talked about the variance when I had just shown you that quick example of how to do the standard deviation calculation based on your formula. So right before you take the square root of your standard deviation, the calculation you get from that is your variance. So if I just show you with this example here, if you just remove that square root symbol, the calculation that you have inside is what we call as the variance actually. Or you will see sometimes they describe the variance as S squared. So if you were to take this number and square it, it would actually end up giving you the variance. So technically that number you have on the inside, the 128.25, is actually the variance calculation. And when you take a square root on it, it gives you the standard deviation. So a lot of times we don't calculate them separately because we know as you're going through the calculation, it will lead you to the variance. But as you can see, this would be coming from the formula. Now, if we are using those built-in formulas, then you will need to do S squared to calculate your variance. So, if we had to do that, let's say we go back to our table here. So you can see we have the standard deviation. So if you wanted to calculate the variance, then we would need to in my example. So then I can add another row and say, okay, I need to know the variance, and the variance will basically be the square of this number. So the number multiplied itself would be a variance. So I wouldn't, want you guys to do any separate calculation. Just find the standard deviation, square that number, and that becomes your variance. And that would be true for all of these variances. And then, you can round it, you have any other decimal cases they want you. So as you can imagine, the smallest standard deviation will also end up having the smallest variance, right? So that's what a variance calculation is. So technically, when we talk about measures of dispersion, we do talk about range, variance, and standard deviation. Those are our three standard calculations. So again, like you have mean, median, mode, and midrange, 4 calculations for measures of central tendency. We have 3 for variance or dispersion, depending on the textbook. So again, range, variance, and standard deviation. 3 measurements to talk about how spread out your data is. So measurement of dispersion or measurement of variation. I think your textbook calls it dispersion. Okay, so the next thing I actually wanted to talk about is how do you do these calculations if you're looking at group data? Because so far what we have done has been, just single values. And that's what 3.3 talks about, is when you're working with group data, how to find your measurement. So let's take a look at an example. So remember, group data means when you're dealing with those classes that we were looking at. So some terminology to be familiar with, we have to talk about the class midpoint. So once you have your, classes for the frequency distribution table, like we had done for the US candy production example. So we're talking about when you're trying to find a class midpoint, it's going to be the sum of the consecutive lower class limit. So you're going to take the lower class limit for, the first class, the second class, add them together, divide by 2. Then you'll do the same thing for the second class, third class, add the lower limits, divide by 2, that kind of thing. And then this one here is talking about how to find your population mean or sample mean based on a frequency distribution. So you do have to start by calculating your class midpoint first. So get your class midpoint, then you have to find the frequency for each of the classes, and then, of course, how many ever classes you have. So let's take a look at an example. Just use this. Please. Does it work though? Because it hasn't worked for me. Maybe it isn't much of it. But it just disappeared.
Page never saved though.
Yeah. That's what I've had to do, is just close it to make it work. Does it?
Sometimes if I hit refresh, it just goes on. Just like, I have to close down.
Yeah, I know they're doing all the fancy Pearson Plus thing, but I don't think it's quite technologically sophisticated enough, because this is the first time ever since it changed it to this Pearson Plus is where I've had trouble with the textbook. But I guess whatever helps us out. All right, so as you can see, we're starting out by calculating our class midpoint. So you can see our two lower limits for the first and the second class were 8 and 9. So we added 8 and 9 together, divided by 2, and that gave us a class midpoint of 8.5. And of course, we'll need to do this for all the remaining classes. So we should be able to see that here on the next page. So you can see here, we did 8 plus 9, which gave us 8.5 for that first class. Then you did 9 plus 10, so 9.5 for the second. Keep going, 10 and 11 would be 10.5. 11 and 12, 11.5, between 12 and 13, 13 and 14, 14 and 15, so on and so forth. Now the last one, or second to last, would be 18 and 19, which would give us 18.5. So even though technically we don't have a class after this, we know this guy would be starting at 20, right? So you would be doing the midpoint between 19 and 20 to calculate that 19.5. So you do have to kind of like introduce that last newer class so that you can find your midpoint. But once you have calculated your midpoints, that's really going to be the main calculation here. Then all you have to do is multiply each of the midpoints with that class's frequency. So then you start multiplying the midpoint with the frequency. Because remember, guys, when you're talking about a frequency distribution, we are saying there were two numbers that fell in that range of 8 to 8.99, right? So either you go back to your original data set and try to find the mean based on, whatever 100 or 1,000 data values you had in there, which in this case would be 40, since that's the total of our frequency column. Then you would have to take all 40 numbers, add them together, and divide by 40 if we were using that regular formula for the mean. Or you can do based on the frequency distribution. So like I said, calculate your midpoint, multiply that with your frequency, and then whatever total you get, divide that by the total of your frequency column. So then you will take 524 divided by 40, and that is going to give you your mean for this data set. So that comes out to be 13.1. And you will, of course, have questions where they're going to have you ask. I think some of you have already made it to 3.3 homework, right? So you should be seeing that in there. So that's what you are doing. Midpoint, then multiply by the frequency, add all those numbers together, and then divide by the total of your frequency column. So let's do a quick example here from our so this is 42. Household winter temperature. So often frequency distributions are reported using unequal class widths because the frequencies of some groups would otherwise be small or very large. Considering the following data, which represent the daytime household temperature, the thermostat is set to when someone is home for a random sample of 750 households. Determine the class midpoint if necessary for each class and the approximate mean and standard deviation. So this will be interesting when we're trying to calculate the midpoint, right? Because they didn't give us evenly distributed classes here, but let's try and see what we can come up with. So let's do class midpoints. Oh, but that would be interesting because we don't have 17. Let's do fourth grade because I don't want to mess around with that. Babies. Okay, the following frequency distribution represents the birth weight of all babies born in the United States in 2012. So if they weighed from 0 to 999 grams, 1,000 to 1,000 to 1,999, 2,000. So that's evenly distributed. That helps. So let's talk about class midpoint. So for the first class, which would be between 0 and 1,000, what would our class midpoint look like for this? Add the two numbers, divide by 2. So while you guys are calculating those midpoints, I'm going to actually transfer this data to a spreadsheet so that way we can use technology. But I do want you guys to try and figure out. We'll need to do class midpoints. And we'll need the frequency. Which is 7.0 to 1,000. Below what we have as frequencies. All right, those are frequency of our babies. All right, so did we come up with what our class midpoint should be for the first class? So remember, that's the lower limit, so 0 for the first one, and then 1,000 for the second one. Add those together, and you'll see I'm putting that in parentheses again. Actually, it should be 500. Because you're using the lower class limits, right? So those are the 0, 1,000, 2,000. So, 500, then you'll be doing the next class would be, of course, the 1,000 plus the 2,000. So 1,000 plus the 2,000, divide that by 2, and what? 1,500. Then you're doing, let's see, 2,000 plus 3,000. And again, divide that by 2, so that should be 25. So again, you can see it's gonna increment with that growth of 1,000 even for your class midpoints. This guy will be going from 3,000 being added to the 4,000. Divide by 2, which would be 3,500. 4, excuse me, plus the 5,000 divided by 2. Now, what will we need to do for this last one? Since you have 5,000 as the lower limit. 6,000. Very nice. So yeah, you imagine if you had another class next to it, that would be starting at 6,000. So you would be going 5,000 plus 6,000. So that would be, 6,000 to 699. But obviously we don't have that class. So you're just using the 6,000. Okay, so this is your class midpoints. Now remember, your next step is going to be multiplying the frequency with the class midpoint. So this is going to be class midpoints multiplied by the frequency. So, yes, multiply. And take it down. So all of these you can see are going to be class midpoints multiplied by frequency. Okay, can you tell me what our total for the frequency and the product here on the right column will be? These numbers and these numbers. I'm kind of hoping you're working on this as I'm working on it, so that way you get to practice with me. Because this is going to be some pretty large numbers. What did you get?
I'm just gonna read this sum of numbers out to you. It's 3,949,000.
Yeah, 3,940. I'm gonna make that bold so we know that's a total figure. Does anybody have the total for the last column? This is going to be even larger. It should be 12,958,000. Sorry, 958,500,000. So what is your mean going to be for these babies' weights at time of birth? Did you have a question? Nikki?
$658,000, 100,167.
That's it, right? Let's check. So we will be taking the total of the class midpoints multiplied by the frequency. You'll take that total and divide it by the total of your frequency. Well, because you're talking about the average weight of a baby, you don't want it to be in 650,000.
Still,
And you can see our majority of the babies were apparently between 3,000 to just shy of 4,000 grams. Oh, I'm trying to remember the conversion from grams to. I know 2.2 pounds makes a kilo.
0.0022.
Pound?
And that's not significant.
Because 1,000 grams makes 1 kilo. Yeah, it would be a very small. All right, so we are saying on an average, all the babies who were born in the year 2012 have an average weight of 3,281 grams. All right, so basically just questions on how to calculate the mean based on a frequency distribution. Questions on the process. No? Okay, let's talk about the next calculation. So we go ahead. All right, so the next type of calculation we're talking about, as you can see, is the weighted mean. A grade point average is a great idea, or sorry, a great example of what a weighted mean looks like. So in this case, we're basically saying if your data values have different weights or different importance, then we have to do a weighted mean. And in the grade point average, like I said, you are basically taking the number of credit hours for each course, right? When you're calculating that, you know, what your average GPA is going to be. So basically, we're saying for the weighted mean of a variable, you start by multiplying each value of the variable to its corresponding weight. And then at that point, the calculations the same. You add those products, divide by the sum of your weights, and you would have your weighted mean. So let's take a look at an example for a weighted mean here. So this is, as you can imagine, a grade point average example. We're saying Marissa just completed her first semester in college. She earned an A in her 4-hour statistics course, B in a 3-hour sociology course, A in a 3-hour psychology course, and C in her 5-hour computer programming course, A in 1-hour drama. So you can see each class has a different grade, credit hour listing to it. So in this case, when we talk about somebody getting an A, they of course get all 4 points for that class. If you got a B, then you're getting 3 points. C is going to equal 2 points. And as you can imagine, D would be 1 point and F would be 0 points, right? So you're taking those points and then multiplying it by the number of credit hours they had. So if Marissa had A in her 4-hour statistics class, that's 4 points for A and 4 credit hours. She had a B in her 3-hour sociology, so that's 3 points for a B and then 3 credit hours. A in her 3-hour psychology, so that's 4 points for A, and then 3 credit hours for psychology, so that's 4 times 3. She had a C in her 5-hour computer, so that C is going to be 2 points, so that's 2 times 5 for the computer class, and an A in her 1-hour drama, so that's 4 points for A, and then 1 credit hour for the drama class. So you can see we take those products, multiply them together, and then add, which gave us 51. That was a total of 16 credit hours she took in this semester. So remember, the weights are coming from how many credit hours she took, right? That's going to be our total. So that's 51 divided by 16, and her weighted average would be 3.19. So at the end of the first semester, Marissa had a GPA of 3.19, right? I mean, it's really that simple of a calculation for the grade point average, but it kind of is nice to know what each of the letter grades, you know, how many points you get for that, and then you can calculate that. So you will see something similar to this example. I think they do another grade point average example in your homework also. Yeah, you've come across that? Oh, good, very nice. So you can actually teach this section.
I
Petrus,
still have more.
yeah. Especially since we hadn't really talked about it in class, so you were figuring it out on your own. So I can imagine that, yeah. All right, guys, look at the difference between the population and the standard deviation formulas over here. Same thing, we are subtracting by 1 on the denominator when you're calculating the sample as compared to the population. So in this case, what's happening is you will notice that we are taking again the class midpoints that we calculated. You're taking the class midpoint, but now you're subtracting the mean from each of your class midpoints. So you will take class midpoint minus the mean, then you square that number, multiply by the frequency for that class, and then divide by the total of your frequency. So again, a very interesting way of calculating when you're dealing with classes as opposed to just static numbers. They're showing you a different version of the same formula here. So you can either use this formula for the population or you can use this formula down here. Honestly, if you're using technology, it really wouldn't matter which one you end up using. So let's go back to our little spreadsheet here with the birth weights. And I did want to do, guess we'll have to create a new column to do the subtraction between, I lost my place. So we will need to do the subtraction between the midpoint and the mean. So we have calculated the mean here. So he's good to go. So let's say this will be class midpoints minus the mean as our next column. And then we will need to create one more column where we square these numbers. So it's going to be the square calculation. So here you will go and click on the class midpoint. And from that, you will subtract where you have the mean. Now remember, your mean is going to stay the same cell. That is not going to change, but your class midpoints will keep changing as you're working on the different ones. So around that B9 cell, which is my mean, I'm going to put those dollar symbols. So that way, when I copy my formula down, it will stay the same B9 for all the subtraction, you know, when you're subtracting by the mean. No, we're going to leave the rounding till the very end, till we get the final answer. So even for the mean, I'm just going to leave it as it is. So those numbers, and let's make this guy slightly bit smaller. So those numbers which were smaller than the mean, so you can see the 500 is smaller than the mean, you're going to get a negative answer here. The 1500, the 2500 were all smaller than the mean. We got negatives here, and then for the 35, 45, and 5500s, we got positive numbers because they were larger. Now, if you try to add this column, what do you think we will get? You can see that comes out to be a negative number, right? So that's not much helpful. So that is the reason why we are squaring this, so that we can avoid working with those negatives. So once you guys have calculated that subtraction, go ahead and do a square. So you can just do, you know, that same cell multiplied into itself, and it will give you the square of that number. And again, you can say yes if you wanted to check that, or you can just drag your mouse down. So once you do the square, you will see all my numbers change into positives now, right? So when I add this column, it's not going to give me a negative answer. So add that. You can see that total comes out to be 17,975,330.76. All right. So at this point, we have done the subtraction of the class midpoint minus the mean. We have done the square. Now, the next step we need to do is actually multiply by the frequency again for each of the columns. So now here, we're taking the square value and we're multiplying it with the frequency. So take the newest column that you just. All right, so take my class midpoints minus the mean square column and multiply that with the original frequency column where we had the number of things. So class midpoint minus mean squared column multiplied by the frequency.
How did you, put in the mean again?
So I took, so like for this, this column, right? So I clicked on the 500. Hold on, let me click on that. So you can see I clicked on, of course, you want to type equal to, then click on the cell with the 500 minus the cell where we calculated the mean. But you will see I'm putting dollar symbols around it because that B9 cell is going to stay the same for all the remaining classes. Yes, we will need that total. But yeah, you will need to calculate these guys for the last one. That's a large number. As expected, because you've done the square and then you've multiplied it with frequency and then you got the total. So it's gonna be a pretty large number. So again, if you guys wanted to see how that last column was done. I'm sending this link to you guys through V2L if you want to have that as a reference. Alrighty, guys, so once you get this total, that takes care of the numerator. So we did the subtraction, we did the square, we multiplied by frequency, we got its total. So basically now we have the total for our numerator. We already have the total of our frequency column because we did that for the mean. So that's where your next step is going to be, so calculating your, let's call it variance, because right before we do the square root is where the variance comes in. So the variance is where you're going to take that total of the last column we just calculated, this number here, and divide it by the total of your frequency column, which was that 3,949,000. So you're dividing it by the total of the frequency column. This gives you your variance. And then the standard deviation is literally going to be the square root of your variance number, this way. And you can obviously do it in one step. You can do the square root of that division, but we're just breaking it up into two parts so you can see the variance. Again, you took that total of the final column that we calculated, that big large number, and divided it by the total of your frequency column. So that is your variance, and then when you take a square root on this, you get your standard deviation.
You see the formula?
So for the formula for this was literally just square root of the variance.
Variance, it was the.
The 429,688.1286, and then you took a square root on that number. So the variance was taken by taking this number here and dividing it by this one. Yeah, so you're taking that final column, which was the class midpoints minus the mean squared, multiplied with the frequency. You took the total of that column and divided it by the total of your frequency column.
That's where.
So again, if you go back and look at this cell here, look at where those two numbers are.
But it's different, but it's like not.
Okay,
Or how you make the answers.
yes, they will make you round.
It's different from my answer. It's like, you're 10,000 a point. or
Yeah.
1,000 a point, it's like that far in. Like, so it wouldn't matter, because in the corner, it's 3 decimal points.
Okay,
Some of them, and they're gonna make it from the other, some other ones are the same, great.
yeah, and that's very interesting because we'll definitely need to look at what was going on there, because I'm not entirely sure.
Because the end formula that I thought I got out of the book and what seemed best after we were done was giving the right answers.
Yeah.
Was in the one block I wrote equal square root, open parentheses, and then my block, close parentheses, divided by open parentheses, a block minus one and close parentheses. And like I said, I'm only off by like 100,000s.
Yeah.
whatever.
Yeah.
But it was like that point.
But it's still enough that it's counting it wrong.
Just on the last question.
Yeah.
On the ones before it. Yeah, it's weird.
And you know, it really is one of those things that I'll kind of have to look at before I can even say what happened. So again, guys, they do have an example of that. The example, oh Lord, what was this on? Oh, mutual funds. But again, you can kind of see they have the same, process. The only difference what they have done is they have created a column for the mean, and you will see obviously it's the same mean for the entire data set, but they just repeated it. We just had it in one cell and I had you guys use the dollar symbol to keep that the same, but that's a different way of doing it. But you will see again, they take the midpoint, subtracted the mean from it, square that number, and then multiply it by the frequency for each of the classes. So you have this example in your textbook also, if you needed something to look at as you're working through example. Now you will see under technology, they do not give you instructions on how to use Google Sheets and Excel because there is actually no built-in function in Google Sheets or Excel to do the frequency distribution one. So you either do it the way I showed you, or if you want to play around with StatCrunch, you can. That would be the other option. I honestly have not used StatCrunch very extensively, so my knowledge of StatCrunch is still pretty limited. There are only, because we mainly use StatCrunch in chapters 9, 10, and 11. So anything you guys do before that is something I'm not familiar with. Because we always use Google Sheets for these first chapters. That's kind of how the department has always done this, so we just follow. So whatever you're comfortable with, of course, this was the example that we used, the birth weights, which is what we based our numbers on. Now you'll see how, of course, we did the mean and standard deviation, but they're talking about draw a frequency histogram of the data to verify that the distribution is bell-shaped. And normally when we talk about human heights and weights, they are kind of supposed to be normally distributed, so they are supposed to have the bell shape. So that would be the same with these kiddos here. So if we had to try and do a frequency distribution, we're gonna need the weight column. And then remember, we'll need the frequency column. Those are the only two columns we would need to graph this. So I'm selecting those. We would go under insert. And then remember, you use the chart option to do the frequency. And it's gonna show you how the differential is going. See, this may be again one of those things where we need to modify. And again, you went from 5,000 to basically 2.5 million. So that 5,000 looks like, non-existent because of the scale. So either you would have to change the scale and see if we could add more values in there. Minimum value and which would screw our data and the largest model. Even now, it's still not showing up with 5,000, even though I tried to change scales. I'm not sure if this is going to work. Okay, so would you say, even though we're looking at a little bit of a wonky graph here, do we have a false shape? Yes, maybe. I mean, you do have to imagine there's a little tiny bar over there on the 5 to 599. It's just not showing up. I mean, it's not going to be a perfect bell shape, but I think we can make the argument that you have the higher number kind of in the center, and then it's making that little normal curve. So I think we could make the argument that yes, it is sort of a bell shape distribution. And we'll have to wait for that third question because we have not talked about the empirical rule yet, but we can do that next time. So honestly, I think at this point we are pretty close to finishing 3.3. So we only have 2 sections left, 3.4 and 3.5. So let's talk about those next class. So we'll definitely not be doing the exam next class because I do want to talk about these 2 sections before we take the exam. So we'll move the exam a week from today and wrap up what we need to with chapter 3. And if you guys have any questions, stay back. I'll be glad to answer them.
but the rest of you are good to go, so I'll see you guys on Thursday.